Let's look at characters. So the character is what it sounds like. It's used to hold a character. So I'm just going to put that this is used to hold a character. And one thing that you might not, that a lot of people don't realize with characters, because it's holding a character, like it's literally holding like a C or an H, is that this is actually an integer data type. So character, I'm just going to put another arrow. This is actually an integer data type. And that seems kind of weird until you realize how these characters are stored. So if you look up the ASCII codes in, I think it's Appendix A, so you can look that up. So characters are stored with their numeric value, which is usually determined from what's called an ASCII code. So the ASCII code is a numeric value that determines a character. Let's say, for instance, we want to represent G. So if you look up G on the ASCII table, it should be equal to 103. So what that means is that G will literally be stored as 103 when you store that as a character. So if we say, for instance, letter is equal to G, and the other thing when we're declaring, or when we're storing a character, we need to use these single quotes around it, and we're going to get to that in a second. Well, I'll just leave it like this for now. So when we store this G as a character, what we're actually storing is this 103. And so that's why the character is also considered an integer data type. So each character, so when we store this character, G or whatever else it is we're storing, this is stored in, well, it's usually stored in 1 byte of memory. I say usually because some systems have, they'll store a character on larger than a byte, so some systems store a character in larger than 1 byte. And so let's, if you look at the ASCII code, like if you look at that table, it doesn't just have letters, like it also has some of these escape characters. \n, the ASCII code for this is 10. And so when we put this \n, it's actually storing that as a character, so it's storing 10, and 10 is this \n character. So this is called the new line character. And so this is stored as 1 character in 1 byte. And so that's why, even though this has 2 symbols, like it has the \, and it has the n, it's still stored as 1 character. One thing with the character is, so we've already seen, say, if we want to store a string, we put a string in double quotes. So we've looked at string literals, and string literals are in double quotes. If we try and store, like let's say that this letter is a character, so we've already declared this as a character. If we try and store a string in that letter, we're going to get a compilation error. And the reason why we're going to talk about strings in a minute, but strings store things differently than characters. So we can't interchange these. We either have to have a string or a character. So now let's look at some character literals. So we've already seen that a literal is something that's hard-coded into the program. So for instance, this A is a character literal, this \n, this B, whoops. So these are character literals. And so what we're doing here is we're declaring a character called letter, and then we're storing A, like literally the ASCII code for A, to letter, and then we're printing out letter. And then we do C out, letter, and then new line. And then we set letter equal to B, so now we've stored B to letter. And then we do C out letter and then new line, and so literally what we're going to get is it's going to print out A and then new line and then B, and then it's going to go the next line after that. We could have also written this as, so we have character, letter. We could have said letter is equal to 65. So the ASCII code for A is 65. So A equals 65 if you look at that table, and B is equal to 66. So if we have something declared as a character, so we have a variable that can store a character, and then we give it the ASCII code for that character, it's going to print out the value of that, what that ASCII code represents. So for instance, if we store 65 to letter and then we print out letter, it's going to print out A to the screen. And same thing we could do, like with this B, we could do letter equals 66. And then when we print that out, since this is a character, it's going to print out B to the screen or to the console. And the reason why is because these, so let's say we have A, B, and C. So this is what so let's say, well, right here we just have A and B, but let's say we have C too. These are stored, so these are stored in memory as 65, 66, and 67. And that's why we can set our character, and this has to be a character. This won't work if we had, say, int letter, because then we're telling it we're storing an integer to that variable. But since we've told it that we're storing a character to this variable, we can then set that variable equal to the ASCII code for the character. And so in this case, if we want A, that's 65. And then so it's literally going to have 65 stored in the memory, and then when we display that, it's going to display the symbol for that ASCII code, which is A. Okay, so let's look at string literals versus character literals. So we've already seen a literal is something that's hard-coded into the program. I'm gonna talk about the string literal first, and then we'll compare them. So we already know that string literals can be any length. Like, we can type out pretty much whatever we want and it'll display it. There needs to be a way to determine how long the string is. Like, when does the compiler know this is the end of the string? Or when does the program know it's reached the end of the string? So need a way to determine string length. What C++ does when we type a string literal is it adds an extra byte to the end of the string, and it puts what's called a null terminator at the end of the string. So I'm going to write that out and then I'll explain what it is. So C++ adds an extra byte to end of the string. Well, end of the string literal. And then it stores a null terminator. So stores null terminator in that byte. And so what this null terminator is first of all, it's the ASCII code 0. So this is the null terminator. And if you look at the ASCII code table, you'll see that the null terminator is different from the character 0. So the character 0, like let's say we have the character 0, this is the ASCII code 48. So if you look up ASCII code 0, it says it's the null terminator. If you look up the ASCII code 48, it says it's the character 0. So these are different. The null terminator isn't 0. So now let's see how this actually works. Like, let's say that we want to store Taylor. So what this is going to do, first of all, Taylor is 6 characters, and it says that it adds an extra byte to the end of the string. So this is going to actually be 7 bytes. So 1, 2, 3, 4, 5. Yeah, 7. So what this is going to do is it's going to store a character in each byte. And remember, this is for the string literal. So it's going to store a character in each byte, and then it's going to put the null terminator at the end of that string. And so this null terminator is what tells the program that it's reached the end of the string. And the other thing is, remember how with the string literals we would put these double quote marks around the string? So these double quote marks aren't actually stored in the string. So if I have this string Taylor, like let's say I did this, so I have cout Taylor, what literally will be stored is this Taylor in 6 bytes, and then it's going to have an extra byte at the end for the null terminator. So basically the string has 6 characters, but it occupies 7 characters. And so that's the case with any string. All strings have one more character than what they actually need. And so this is the issue with why you can't mix the characters and the strings, because they're stored differently. So let's say we have A, so this is a character, and let's say we have A as a string. So they look the same, but they're stored different. So the A is going to be stored, like, so we have A, and here's the byte that is stored in. This is going to be physically stored as 65, but this A is, since it's a string, is going to have an extra byte added to it for the null terminator. So this is going to have A and then \0. So this is going to be stored as 65, and then it's going to have the null terminator. And remember, the ASCII code for the null terminator is 0. So, but it's not the same thing as character 0, which is ASCII code 48. So that's why if we did character letter, so we declare a character, so we declare a variable that's a character named letter, we can say letter equals A with the single quotes, but we'll get a compilation error if we say letter equals A, because this is a string, so we can't do this. Actually talk about the C++ string class now. So the string class, first of all, the string class allows us to declare a variable that can hold an entire string. So declare a variable that can hold an entire string. And this is really nice because if you think about it, like if you had to type a string with a bunch of characters, you'd have to do a character array. That can get kind of messy. We're going to talk about character arrays when we get to arrays, but the string is a lot easier to deal with. So C++ doesn't actually have a built-in string data type, and so we have to use the string class. And so if we want to use strings, we use this #include string. And then this allows us to declare a string variable. So if you try to declare a string variable without this #include string, you're going to get a compilation error because the compiler doesn't know what the string is unless you include this class. So make sure that you use the #include string. And then we can do things like, let's say we have a string movie title, and then we can store an entire string to that variable. So we have the string movie title, and then we have movie title is equal to Wheels of Fury. And notice how this is in these double quotes. So you need the double quotes. If you don't have the double quotes, it won't know that you have a string, so you'll get an error. And then you can print out like any other variable. So cout, my favorite movie is, and then just the name of the variable, which is movie title. So this is going to print out, my favorite movie is Wheels of Fury.